Hello listeners, welcome to another lesson. Just want to start off today with conductive heat transfer. Now this may seem daunting, might sound crazy, but if you break it down, the first step is learning how everything kind of fits together, and I hope this equation will help you learn more. Essentially what it is a transfer of energy between two bodies of differing temperature. So you got your Q dot, which is your heat transfer rate in watts, also known as joule per seconds. Your K factor, which is a constant for the material, which is pre-calculated, and you can look that up on Google or in your textbook or whatnot. L would be the material thickness, which you're transferring heat through. And A would be the surface of that material, the surface area of the material. And TH and TC are going to be your temperature difference between the material that's hot and the material that's receiving the heat. So just to fill you in, I kind of drew up like a real-world example. This is a toilet seat and a human. So like I know people have sat on warm toilet seats, and this kind of explains a little bit about why that might be or how that all works. So essentially it's really not about the person even as much as it is about the seat. So like if you have a seat that's maybe at a higher temperature to begin with, or a lower temperature, or it's a thinner seat, or it has a smaller area, these could all be factors that go into why you feel that warmth when you sit down. But also with the human, they can be affected because of the area that they take up on the seat. So like if there's a person who's a little bit larger, maybe, person a little wider, they can transfer a little bit more heat. But if you got like a more smaller person, then their area wouldn't be as much, so that value would go down. But this just kind of shows you how all the numbers play together. And you got your temperature of the human, 98.6. Temperature of the seat, I assumed was 72. The area between them, I assumed like 0.2 meters. And then the thickness of the seat is 0.1 meter. That's another thing. If the seat is thick, it won't transfer as much heat. And then the K value for a human is 0.34 watts per meter Kelvin. So when you plug all that into your equation, it's a simple calculation, and you get a value of 180.88 watts, which is joules per second. That would be your rate. But I hope this helps you a little bit. Please like, subscribe, comment if you'd like to know more. I'm coming out with more videos to help you guys out. So thanks for listening, everybody. Have a good one.